name is Eugene. I'm from the International Doctoral Training Innovation Center and Computer Science. And I represent the Big Data and Visual Analytics Lab. We are a relatively new lab. Okay, relatively new lab. At the moment, capacity building. So I have 8 summer interns, building foundations from server architecture and so on and so forth. We are associated with the IBM Visual and Spatial Technology Center at the University of Birmingham, where I previously worked, dealing with geological and ancient data sets. I'm also associated with the Center for Creative Content and Digital Innovation, University of Malaya, doing similar work in big data. When we talk about big data, we have at present 7 Vs. Whether it will increase or not is a question. But I think human data, human-generated contents, deals with most of the 7 Vs, whereas machines produces not many Vs. Issues is not in many of these Vs, because humans are very creative and particularly very opinionated in social media. Data is the collection of facts, figures, and statistics, perhaps, but what's meaningful is to acquire information from the data set. So relationship between the data sets is particularly important. And the fact of life is that everything is connected. So in big data, we have the capacity and the functions of the machines to deal with connectedness automatically. This will allow us also to zoom out to see the average of the data sets, but also to zoom in to see the mechanisms that produces the phenomenon in the average of the data set. So we deal with social network analysis in this instance. We have architecture set up both in England, but also in Ningbo campus. We have this sort of setup, which is currently being in development with 2 and 3 data going out and coming back in visualization. But we use Node.js a lot because it's non-blocking asynchronous output, and it's built on Chrome's V8 engine, which is really powerful. So our data sets can be very in a very huge volume, but also high velocity, and we can take all the data sets, no problem. Then we distribute our data as key pair values in MongoDB distributed sharding, but also in fast memory allocation, we use Redis. You'd be quite surprised that many of the top journals which deals with social network analysis are manual and not automated. They publish some really good data, but it's all manual. And the data, if you're collecting it manually, analyzing them manually, it's rather tedious. So big data will really contribute in the future. We have been modeling and mapping multimodal longitudinal activity networks. If you look at my Twitter, I've got 435 followers. I follow 719, but we rarely have activities. I rarely interact with them. But when it comes to topical events, then there definitely is a lot of interaction. So mapping the follower-following network is not really useful because there are not really a lot of activities. So we have been modeling and mapping real interactions between people in the real events, and that brings us something really interesting, which I will show you. So I've been looking into Free Johar, which is the main topic here, and also election data from PRU 13 from Malaysia. NSA, I'm not spying, but I'm mapping people's reaction on Twitter with regards to NSA spying on people. I mapped the royal baby, Madeleine McCann's kidnapping case, and MH370. I wasn't in my server, so I didn't capture MH17. You can see that I can't see the mouse, but anyways, each of the data points, you see many data points and there's a signature, okay? But each of the data point is one block of interaction. So any picture from the medium to the bottom row is our interaction networks. And it's just one single point in that flow of data. But when I reduce the nodes, which are mostly retweets, okay, you just retweet, I find that there are some interactions which is quite interesting. For example, in the Malaysian election, last May, you have two parties and they are really, really separated into two groups because they talk to each other by intermediaries. But you see the two groups and the opposition became really powerful because of the media groups around it. And that's really interesting. In the Madeleine McCann kidnapping case, the question is, why are there many, many small clusters that are separated from each other? Is it because people have kidnapping experience in their family or relative or friends? So this is a question, and we're currently analyzing the data sets. So this is one single data set, single data point in the network, and that's MH370, 82,000 nodes. When I reduce that to 25,000 nodes, you can see that there are some really important people. Are they politically motivated in this instance when they talk about and interact with regards to MH370? In another data set, you see another person. The person is probably no one, but the importance of that person in the network is that. So this is the interesting part. I started doing this work when I saw this. Boston Marathon bombers, it's big news in the United States and in Europe. And the strange thing is that, not this, but the two brothers, one of them is quite good looking. So teenage girls, American teenage girls, whether they are whites or whether they are Muslims, they fell in love with the young terrorist and said that he's too cute to be a terrorist, so free him. So I started capturing data, just to see what they have. And these are some of the tweets that they tweeted. It's rather controversial. And they've been also posting pictures of themselves, making a statement, a rather strong statement, with posters, popularizing the person, the extreme devotion. But what really happened in Twitter is more interesting than their behaviors in other online media. So I'm going to skip through this. It's mainly theoretical, but the traditional concept of community is maybe territorial and geographical. But in the online community, things changes. Okay? It's more relational, more topical, more interest-based rather than territorial or geographical. So modern society develops community around interest and skills more than around locality. And I'm going to just skip through this, but in community, you can see membership. So the question is to test whether a real community exists within Twitter amongst these teenage girls, using automated approaches. Okay, I'm just going to skip through. So based on these few questions, after my paper is published here, I analyzed further, and this is in other publications, so it's in review in 2 journals. So from the data set, you can see that some of the points are rather big, so it shows some activities. But when I measure them against certain network measures, for example, average path length, number of shortest path between the nodes and retweets, how many Twitter users are there, how many community-based clusters are in the network, you see some top-ranking data sets. So those are the data sets that have real activities. And when I do some regression against two variables, you can see that certain data sets also come up at the top, 759 for example. So and that's the power law distribution for the number of retweets that each person gets in each of the data sets. But looking at the signature of the data sets, you can see that there are large circular clusters surrounded by black nodes. Those are retweets. But in the picture, you can actually see that there are expressions of large groups of people talking with one another. And this is where we can find the community in Twitter, for example. So looking at the 759 data sets, you can see that at the top part of the landscape, there are large clusters of retweets. Those are CNN News, Boston Globe, Guardian, BBC, and so on and so forth, Yahoo. But at the very top, there's a big, messy cluster. And this is where the teenage girls exist in Twitter. So it's really interesting. These are some of the conversations that they have. So you see, it's not merely a follower-following network. It's actually an activity network. Who talks to whom over time. I have a video here. It's working. And you can see the data set 759, the evolution of the network over time. As news come in, and as they begin to talk, okay? And it will become this picture, just to see. And the degree centrality, the top part are the most important people because they're networked. The grasshopper, that's one 19-year-old teenage boy. When he tweets, thousands of people tweet. So it's not really important. Looking closely at the closest centrality and the between centralities, you can see that there are a few people who are more important. And this is interesting because I've only 2 minutes. You can see that the centrality exists in the cluster of teenage girls, and which means that the news channels are mainly publishing news. But the activities, the thing that maintains the small world network is this group of teenage girls in argument with the green bloc of pro-American people. So they're arguing against each other, and that maintains the network. So they pull in information from news sources to fuel their arguments. When I analyze to see if there are leaders in the group, actually it's a bottom-up organization. There are no leaders. So over time, they are all equal. The activities are equal. These are other data sets, and I'm going to just end this with the final data set. Eventually, most of these young teenage girls, because they broke the policy of Twitter, they were disconnected from Twitter. Their accounts were closed. So eventually, the community became fractured, and eventually they became non-existent in Twitter. So over time, over a few months, they were there interacting. So there was one article by Chris Anderson. When data becomes big, will it change theory on general understanding of theory in the social sciences? In my analysis, community-based interaction remains. And the sense of community is there as also in physical interactions. So I'm going to stop here. 13 minutes.
Thanks for Eugene's excellent talk and amazing figures. So, any questions? We have 2 questions.
Hi, great talk, thanks. My question is, I wonder how you're collecting the data. I understand that you're querying Twitter API to collect the data using hashtags or keywords, whatever it is. But you said that you're interested in the full handshake and the interactions between users. And understand this to be activations, so user A mentioned user A meeting user B responds to user A, and so on. The problem is once you query the API using a hashtag, you're going to get one of the mentions. But usually users stop using the hashtag and they keep going with their interaction through time, and you miss that because the parameters of your search do not comprehend that. So how are you following up this, how this conversation is evolving through time?
Okay, the idea is not to use the query function of the Twitter API. The idea is to use the streaming function. So as data is produced, it streams through my servers, and everything is captured. So streaming allows you to capture actually much more than the limited query that you are allowed to. When I check my data against the data on my browser, they appear to be equal. So all the data seems to be captured. That's why you don't have gaps between the links. When I tested my server in Weibo, there are a lot of gaps because Weibo simply doesn't have streaming. You have to query or get data as they come in from the repository, I think. So I don't know if that answers your question, but streaming is the keyword.
Hi, thanks for the I'm Carol Song from Purdue again. Thanks for the interesting talk. I have a question. So I'm less interested in these hot guys and what people think of them. And so I'm mostly interested in scientific work, how citations work. So I'm wondering if you have thought about or applied your methods on citation work. That would be
Yes.
huge.
I included a slide which wasn't in my thumb drive. Last year we published a discovery with the IBM Visual Spatial Technology Center on the world's oldest calendar. You must have heard of it because it went all online. It went viral in Twitter too. And it was at the science page of Google at the top rank, so the world's oldest calendar. And prior to that, I knew that something will happen, so I started tracking the streams of Twitter. And we have a publication in preparation comparing outreach or impact, these two. Our work is widely cited in the news channel, but perhaps not yet in the impact factor journals. So how do you compare the two? Is it outreach? Is it merely an outreach, or is it impact to the scientific community within our work? So we haven't submitted the article yet, but if you want to have a chat, I can show you some of the pictures. National Geographic highly publicized our work at the time. Thank you.